welcome. My name's Hamish Mackenzie, and we are now at the session AI Hype Meets Reality, What's Real, What's Working, and What's Next, sponsored today by Arch Systems and Skynet. As usual, please feel free to tell us who you are, where you are in the chat, so we get a feel for who's joining us. And I'm going to be introducing our guest speakers in a minute. And obviously, we're going to get a lot of valuable insights from them, but we also want to have your questions as well, because you're who we're doing this for, and we would love to get your questions, and we'll get to as many of them as we can at the end of the session, last 10 minutes or so. And please put those questions into the Q&A function. You'll find it at the bottom of your screen. If you can't see Q&A, just click on More, and you'll see it in there. Put them in there because it's easier for me to find them. It's just a very pragmatic thing, and you're more likely to get your question answered if you get it in the Q&A function. All right, so with that said, in this session, we're going to be cutting through the noise around AI with proof talking about real agentic AI running today on real factory floors. We're going to be discussing areas, but also why manufacturing AI isn't delivering. So a lot of the cognitive work operators and engineers don't like, deciding how to automate all of that. And we're also going to be looking at a roadmap for predictive maintenance, broader machine applicability, and autonomous factory workflows. And to help us do all of that and more, we have some very special guests with us today. And I would like to introduce you to them now. So we start off with Andrew Scheuermann, who is CEO of Arch Systems, our sponsor today. He is the CEO and co-founder. He has a PhD in materials science from Stanford. He's published a wide catalog of scientific papers on semiconductors, electronics, renewable energy. He helped build the StartX Accelerator, which invested over 200 million in startups. And he's an experienced technologist, entrepreneur, and advisor in Silicon Valley. So thank you for joining us again, Andrew. Next up, we have Gary Tillery, who is CEO of our other sponsor today, Skkynet. He's also a board member there. And Skkynet is all about connecting your plant floor to cloud systems, corporate IT, and remote operations without the firewall exposure or VPN complexity that attackers exploit. He has 35 years of experience in the industry across software development, system integration, strategic partnerships, and M&A. He's a former senior director and strategic portfolio partner and M&A at Aviva, formerly Schneider Electric, of course. And he's held various senior leadership roles there, spanning software development, product, partner management, all sorts of things. Thank you for joining us today, Gary. Then we have Dave Morse, who is SVP and GM of Industrial Automation at Delta Electronics. He's been there for nearly 30 years, and he has had roles over those years spanning product management, sales, director of sales and operations across power supply and industrial automation business groups. And he has degrees in both electrical engineering and civil engineering. So thank you for joining us, Dave. Then we have Pugal Janakiraman, who is industry principal manufacturing at Snowflake. He has over 20 years of experience in applying technology to industrial digital transformation with deep expertise in automotive, trucking, heavy machinery, and aerospace OEMs, including China-based manufacturers. He's also the former worldwide business development lead for industrial IoT at AWS. And he's also the former leader of digital twin and real-time operational intelligent practices at Siemens. Thank you for joining us again, Pugal. And finally, a few words about me. I am a former IDC analyst. I've been running my consulting practice here in Munich, Germany for the last 20 years, and I consult on multiple aspects of go-to-market strategy for all sorts of different types of software companies, industrial, deep tech, various different markets. And I focus on providing the focus, clarity, and execution leverage they need to turn complex technology into reliable growth. If you want to find out more about me, look me up on LinkedIn. I'm the only Hamish Mackenzie in Munich as far as I know, so it shouldn't be too hard to find me. Quick reminder, get your questions into the Q&A function. Don't wait till the end. As soon as you think of something, get it in there, and we'll get to as many as we can by the end of the discussion. All right, so let's get into it then. I want to start off with a bit of context. And this is going to be a bit of a broad brush question, Dave. But I'm going to come to you first. What does a real AI-enabled manufacturing environment look like today from your perspective?
Today, we would never call it an AI-enabled manufacturing environment, right?
There we go.
Yeah. Today, I think most manufacturers are still in the old world. Maybe, 20-25% of manufacturers have actually moved into what I would call smart manufacturing. That is the term that we use today. Smart manufacturing definitely incorporates some AI into it, but it is not what I would consider AI enabled. And, For smart manufacturing, typically you're going to have at least 30 to 40% automation on your factory line. You will have a significant amount of sensors. You will incorporate IIoT, right? The industrial Internet of Things.
Mhm.
You will do a fair amount of data analytics. That could be some basic analytics on a PLC. It could go up to a SCADA system, and certainly it will go up to a higher level system that is using some of the software from the gentlemen that are on this board. Um, so that in that smart manufacturing space, which is pretty big right now, I would say you're looking at 20 to 30% of the manufacturers today using
Mhm.
it, 20 to 30, or maybe even 40% of manufacturers wanting or planning or investing to use it. You still
Mhm.
have significant amount. It could be 30% or more. They have no idea. It's still manual labor and it's still not
Mhm.
automated to the point that we would consider automation. Um, and inside that, we were talking about it earlier. I think predictive maintenance is big. It is being used today in almost all the smart manufacturing locations. I think data collection and analytics is used in all of them. What is starting to occur more often than not is the digital twin. That is pretty big in the AI space.
Mhm.
That's where things really change. You go from that physicality to a digital flexible environment where I can change my assembly line quickly. The entire thing is simulated in a computer. Instead of having a discrete number of, say, 5 recipes that my assembly line can do, I now have a digital assembly line that I can change quickly and implement very quickly into something else. So that's where I would say we are. We're really in that infancy of smart manufacturing, and we're still years away from AI enabled.
Okay, fantastic. So that gives us a realistic picture of where most companies are at the moment. All right. So Gary, I want to come to you next. Could you talk a little bit about, I mean, assuming, we are talking about AI and a lot of people are already talking about agentic AI being, active in factories. What's, from your perspective, the kind of honest test that separates a genuine agentic AI deployment from a sophisticated dashboard that someone is just calling AI, Gary?
Yeah, hey Michelle. So a lot of what's being sold or proof of concept, I should say, as a generative AI right now is just better visualization with a generative UI layer on top,
Hmm.
right? The distinction kind of really matters when you get it down to it, because we're talking about in a safety critical environment. It's a big difference. The test you can kind of look at is just kind of what agentic AI is in general. It's the system. Does the system perceive, reason, and really act in a closed loop? Or does it surface an insight and wait for someone to come do something, a human? Most industrial AI today, it does the latter, right? It's a dashboard, tells you something that happened. A diagnostic model can tell you why. Agentic AI can act on that independently and you can kind of achieve different goals that you've actually set, whether it's actions or other, with minimal human supervision. So when a agentic AI acts or closes a value, a valve, I should say, adjusts a set point, schedules a work order, is writing back into the OT environment. And that write back kind of pathway must be authenticated and audited and architecturally constrained so that a compromised agent can't become an attack vector for someone. So that's the other piece on any AI that you want to kind of think about at the same time.
Hmm. Okay, and so what when we're talking about real AI, what are we actually talking about then in your experience over all the installations that you've seen?
So, what's real is in the AI conversation is manufacturing skipped two foundational problems.
Hmm.
The most vendors like they don't have an incentive to actually put on the table because solving them isn't what they sell, right? The first is the protocol reality. We talked about it before this a little bit. AI models expect clean, structured, normalized data, JSON, MQTT. It's got time-stamped engineering unit values as an example. The OT floor speaks, entirely different languages, OPC-DA, Modbus RTUs, proprietary DCS historian formats, legacy serial protocols, if you guys are old enough, you can remember those, right? But they run on equipment that's like 20 or 30 years old. So if you bridge that gap before selling the AI platform, they're not even thinking about it. So the second security is security, the moment you try to move OT data towards a AI analytics layer in the cloud or somewhere else, for that engine, you need to kind of face a choice between inbound firewall ports into your OT network or don't get the data. The bad actors, threat actors targeting industrial PLCs. We've seen some reports on that. I was at CSA conference last week. There was a lot of conversation around this. And a recent CISA advisory article came out talking about some bad actors attacking these PLCs that are connected directly to the internet. So underneath both of those is the pilot problem, right? Most manufacturing AI exists in control proof of concept environments with pre-cleaned data sets and vendor engineer on site. And when that pilot ends and the data pipeline reverts to reality, if they actually get that far, you got real world situations happening. Now you got shift changes, you got process variation, you got legacy devices dropping off, coming back on. The kind of model fails because it's no longer in that pristine environment.
Hmm. Hmm. Yeah. Yeah, no, we heard a lot about that in the last session that I ran this morning as well. All right, so we're going to come and talk in a little bit more detail about some of the specific challenges in a second. But before we do that, I just want to get Andrew and Pugal's input on this kind of contextual piece. So Andrew, if I come to you first, what is your view on what's real at the moment in terms of AI in manufacturing?
Yeah, real is specific use cases that can use the subset of the data that's ready. Not
Hmm.
real is the whole thing and everything.
Everything
Dave
else.
described the physical layer, the grounding. Gary described how most of the world is still in that serial protocol Modbus OPC DA. Yeah, you got to get to OPC UA, you got to get to modified tags, you got to get to enterprise context, full data twin, then AI. So does anybody have that whole unified model together and they're doing AI on everything? No. And that's hype. And when people start using it not grounded in data, that's hype. But I don't want to guess what Pugal is going to say. But folks at the enterprise layer like Pugal know there's a ton of really interesting enterprise context data as well, which when combined with a subset of the factory data, you can do amazing things today. So, for example, planning is a really interesting category where you can have an AI agent planner. It uses a bit of data from the ERP. And even if just a few machines are connected with a cycle time, it can inform and update a real schedule, right? Another example is the predictive maintenance we were chatting about. Do people have predictive maintenance on every machine across the entire floor? No, nobody does. There's a couple like highlights here and there, but you can combine the highlighted predictive maintenance with an agentic system, which automatically fills out tickets and reads the manuals and tells you how to fix it faster, right? So if you pair the real use cases, which means kind of context unstructured data for guidance with like the subset of a live factory data, you get real use cases. And again, that's like ground in real data, realizing you can use unstructured guidance data for the first time. That's what people are excited about. And it's so hard to tease it out because both are true at the same time. There's a handful of examples of amazing stuff that's uniquely possible. And for everything, we're a long ways away from plumbing and wiring up the whole factory, both true at the same time, right?
Right.
Okay. Okay, Pugal, your enterprise perspective on top of that?
Sure. I think I'm not going to say anything new. I think people are pretty much the same thing here. I would say that what is really working is start with an area where you got a pretty good data quality available. That is both IT and OT data available. And also with a business use case perspective, like Andrew mentioned today, that's what is working. It's not a holistic, I can go and change everything for Industry 4.0 or smart manufacturing. I think that's where the industry was 6 or 7 years back. Now there is some level of rationality that it's not that easy to get this data organized semantically to make sure that it can drive business value. I think industry has realized it. And also, it's not an IT-driven initiative anymore. It's business-driven initiative where the business wants to see a value on top of it. Again, if I go one level deeper into a use case like maintenance topic, predictive maintenance, I'm not sure how many people are really doing it, but they also have realized that they have to work on very precise use cases, even within maintenance in general. How do I get into streamlining analytics as far as RCA is concerned? Whether the machine goes down, or there is a quality issue happening, or there is a throughput issue happening at a plant level, how do you perform an analytics? They all have realized that the real challenge is running that analytics, because getting access to the data is the first issue. Even if you have access to the data, most of them are running analytics with Excel spreadsheets. How do you move them away into an AI-based toolkits where you can run analytics and streamline that? Because 60 to 70% of the time of any RCA process is spent around analytics. And there is genuine value in leveraging AI to perform that analytics instead of humans trying to do with some Excel macros. That's where more and more of these engagements are happening. Again, Snowflake as a data and AI platform, we support these enterprise level use cases where you are trying to streamline these kind of analytics. That's what we are seeing more and more traction now.
Okay, fantastic. Thank you. All right, so let's move on now to talk a little bit about some of the challenges around this. And one of the big topics in my last session was was the idea that, or the fact really that, a lot of manufacturers are having their, doing their pilots and they're getting great results, and then they, they go to the bosses with the great results, and then they say, okay, fantastic. Well, let's just roll it out then. We'll get going. And then they say, well, yeah, we don't actually know how to do that um, when we're taking into account all the unstructured data and everything else. So if it is the case that only a very small proportion of companies are actually managing to realize financial benefit or business value from AI at the moment, um, what is it that is or what is the difference between a company that's able to move from a pilot, say, into a scaling, into scaling the solution properly, to those that don't? And if I can start with you, Andrew, on that one.
Yeah, sure. So this tension we talked about in the last is really at the heart of this. And
Mm,
at Arch last year, we called it the year of end to end
mm,
because manufacturers were like, okay, if I'm going to use AI, I want to use it end to end. There's this desire. I want to use it for planning. I want to use it for quality. I want to use it for maintenance. And can most factories use it for literally all cases today? They can't. And so that's a tension. But the change management is really significant. And they want to try to pay the change management fee once. So it's just a good thing to call out. There's this constant tension between, okay, maybe I'll wait until all use cases are ready versus roll out just one little use case. And there's some kind of sweet spot in the middle where you've got 4 to 5 use cases, a lot of business value worth paying the change management fee that every manufacturer has to navigate. And that's a challenge, right? So you go to your question, Hamish, which is really like the AI financial gains. It's about use case and it's about seeing that use case actually go at scale across plants. And the first challenge is, do you actually have the data hooked up and a real use case defined? And then the second challenge is change management. And that's where if you've only got one use case, you'll still see resistance from the plant of like, this is a whole new way of working. So like look at guidance and recommendations, but it's only helping me on maintenance on one machine. Like,
mhm,
what am I going to do with that? Oh, it's helping with planning. Oh, it's helping me with quality. At some point you reach this critical mass. And so what we've actually seen in the industry is that much to our investors are less happy about this, but the pilots have gotten bigger and harder because the customers want to see, correctly so, more use cases proven. And when they've got a critical mass of use cases, then they know that, and then the ROI actually potential has gotten far bigger because there's not one, there's 5 use cases, not 200, 5.
mhm.
And then they pay the change management fee. And then when they really roll it out and you see real usage of people putting it into play, that's when the financial results roll back in and you can see the KPIs change as a result of what you're doing. Again, compared to the ones that did it once, exciting POC, either the connectivity wasn't there, so they couldn't roll it out, or they tried to roll it out, but the change management blocked them, and then they don't see a change in their overall quality, downtime, whatever it is.
Okay, right. Thank you for that, Andrew. And Dave, what's your perspective on this? Separating companies that can successfully scale from those that can't. What's your experience?
It's interesting because I come from more the physicality of it
Mhm.
versus the software of it, right? And everything that's being said is so it's so obvious to me because I'm in it every day, right?
Yeah.
Uh, We see that they are, and we're talking manufacturing, AI in a manufacturing space.
Yeah.
Um, we see the companies wanting to do these pilots, and they invite us. And we have an exact example, right? Right now, I have a team down in Texas, and we are installing an entire assembly line that was done on a digital twin, and that all the machines were manufactured from this digital twin. The entire thing was simulated on the digital twin, and we are now installing it and running it. It will work and it will be great, but it's too pristine. And when we get it all said and done, there's the upper level that still isn't connected, and that's what I think is what Andrew is saying. It's absolutely what Pugal was saying, and I'll take Gary's comment of the physical layer. Andrew's saying it's all these connected pieces. Well, that's great. I've got this assembly line that's running. However, it's not connected to the ERP. The
Mhm.
assembly line's great. It's all AI driven. It works awesome. They can't even get the product to the assembly line to produce, so the raw material's not coming in. They haven't finished or figured out how to get it off the assembly line into the warehouse. They don't have an automated storage and retrieval system like an ASRS. It just falls apart because they just don't look at it from end to end, as Andrew is saying, right?
Hmm.
Uh, the other aspect that we see, and I'll take Gary's comment, it's amazing that we see factories every day. We walk in and they are old school, right? You know how clean room factories, I call them dirty room factories. They're just nasty, dirty factories, right? They're disgusting. And they're running 30 different network protocols. And they say, hey, we saw this AI work and we thought it would work here. And I just look around and say, there is no way this is going to work. It's a complete disaster. And we try to explain to them that I can make this machine work or I can make the factory work, but to make the whole thing work is different. So where I'm going with this is I believe those who scale have a better understanding of AI. They will get somebody on their staff. They will get consultants. They will talk through it with everybody for years. They just don't jump in. Um, they will do a couple of pilots and they recognize it still doesn't work. For us, we're a manufacturer of our own hardware, right? So we make the product that we are selling. And we even recognize there are certain areas where AI is helping us. There are certain areas it's not, and there is no ROI, and we're not using it.
Hmm.
Um, Kind of goes full circle to the earlier question. I still think we're years out to that level. But scaling is knowing. You got to know before you can scale.
Okay, fantastic. Yeah, it reminds me. I'm sure we all know that old phrase that no battle plan survives first contact with the enemy. And what I always say to my clients is, no AI strategy survives first contact with the existing infrastructure. So it's just reality, right? So
Mhm.
anyway, thank you very much for that, Dave. Gary, if I could come to you, so what's your perspective on in terms of what's not working in these AI deployments when it comes to scalability?
Well, first I got to add a different quote for you. It's from Mike Tyson. It says, "Everybody has a
Yeah.
plan till they get punched in the face."
Yes,
That kind
exactly.
of describes what we're talking about
Yeah.
so well. But I think it all begins in the beginning, where I saw a cartoon recently, a guy asking a bunch of CEOs, "What do you want?" "I want AI." "Why do you want it?" "We don't know." "Do you really want it?" "Yeah, we want AI," right? So it's a little bit of the hype, but you need to understand your organization. Your organization transferred, are they transitioned over to working this way? If you're preparing them? And secondly, you really need to fall in love with the problem. What problem are you trying to solve or problems? What is your strategy? What are your opportunities you're chasing? If it's efficiency, if it's other things, other insights across multiple lines, multiple plants, whatever it might be, you really need to understand that before you just start going out and finding the latest AI model and engine running. The, the other thing is around that foundation first. We kind of talked about this a lot. It's reliable data, but it's clean data. To Dave and others' comments, is you have to architect your data layer. This is not like throw something on top of it and then you're going to magically have the light switch turned on, clean, pristine data in a modern format. And then the model comes second. Then I think that you can look at trying to scale from there. But really not saying anything new here, but it's definitely things to think about that are not technical at all before you get to the technology piece.
Hmm. Okay. Pugal, your input on this topic?
Yeah, I think scalability wise, between a pilot to production scalability, the biggest challenge I see is around there is no standardization between two different locations of manufacturing facilities. Because
Hmm.
nearly all the companies we work with have got multiple plants, and these multiple plants came in through most probably through acquisition. And the IT and OT footprint, 100%, it's not similar. It's like you can bet that it's going to change between a plant to plant. Even if you identify a specific use case and did a pilot on a specific location, there is no guarantee the same customer, even if they are producing same part in, let's assume, between US to Asia to Europe, they're not going to align on the same business use case. The priorities are different. The labor cost is different. Their supply chain strategy is completely different between Asia and Europe or North America. So the alignment of use case doesn't happen. So when you are trying to do a pilot, the best practice is try to do a maturity analysis of every one of your plant infrastructure to see if they're ready for a smart manufacturing scenario. If so, what is the business outcome they are interested in? Most probably they will ask for different use case. Their IT and OT footprint is different. If you think this through, and if this planning is done properly, usually the pilots reaches production scalability. Otherwise, there is going to be friction at every point I can think of.
Fantastic. Thank you very much, Pugal. Okay, and I guess, one of if it is true that most companies are not seeing a return or the return that they would like to see on these projects, perhaps one of the reasons is that they're misallocating their investments into AI. So, Andrew, where do you see leadership teams most often investing in the wrong things or putting the money in the wrong places?
I mean, first I'll say I think the still number one mistake is doing nothing because
Yeah.
this is a big wave and you need to figure it out. And if you're unintentional, your people are kind of doing it for you. And so doing nothing is very similar to making the laziest, less guided choice for your organization. So that's definitely the first mistake. The second mistake I would say is swinging too hard the other direction. There's a lot of us here in the call that sell automation and connectivity, but if you just go all connectivity, or all SCADA or all MES, kind of the last generation of technology, the ROI and payback of those hasn't changed. And they need their proper timescales and they need to be put where automation is high. And so if you do them just because AI, you'll actually see negative returns, right?
Mhm.
So then, okay, I've got to do something. I've got to connect the base layer. I've got to have real use cases. The third most common, I think, mistake is you allocate everything purely into a chatbot use case instead of going the last mile and figuring out embedded workflows. Embedded workflows are what create value, but they're hard, and you got to understand how your people work. So you're closer with the chatbot strategy. I'm not trying to demean it altogether, but it's kind of the easiest thing to pair with just throw a bunch of data together in chat. And like a dashboard, it's too easy to ignore a chatbot and not use it and not have any governance and control over the way people use a just pure chatbot. And so it can be kind of an isolated strategy that then doesn't get you there. And everyone's asking, like, why did we do this? And if you don't land integrated workflows, you don't build the confidence in your organization that you know what you're doing, create the ROI, buy some more connectivity and underlying layer, do the next flow or do the next workflow. So it's about like getting through those, I think, misallocations of capital, too much connectivity for connectivity's sake, or just chatbot and actually defining the workflows that you need, which is just simply hard work. But committing to that and getting through it is what takes you to the other side.
Yeah, so much. So many people often ignore the fact that hard work is still the key to a lot of success. All right, thank you very much for that, Andrew. Just a quick reminder to our audience: please get your questions into the Q&A function whenever you're ready. Don't wait till the end, and we'll try and get to a few at the end of the discussion. So we focused on a lot of the challenges. I think it's now time to put a more positive spin on anything, and let's look at what is working. So, Pugal, if I could come to you first, what would you say is working well around AI within manufacturing? And perhaps you could also just give us a little insight into Snowflake's priority and approach around AI in manufacturing.
Sure. I think if I had to look at our priority and approach, I think I would say that our focus when we started into smart manufacturing around 4 years back is to make sure that the data ingestion from IT and OT sources can happen seamlessly with highest possible fidelity, because if there is no data, there is no AI. That was the first activity we took. And also it was a OT-centric approach because as Gary mentioned, there are 300 protocols in which machines talk to each other. IT side of it is pretty straightforward, bringing in that IT data. Complexity always is in the OT side of it. How do you get the data from machines, PLCs, SCADA system, or in process manufacturing, the data is sitting in on-prem historians. Unless we can get the data contextualized and make it available in the cloud infrastructure, along with IT data semantically organized, getting value is not a trivial thing. That's the first thing we had to sort out. Once that is sorted out, the game of AI becomes much simpler as long as the business use case is present on the table and there is an executive level sponsorship around that business use case. That's what is working. As long as that happens, then it's fine. And also start with, I'll go with what Andrew said, not doing anything is not a viable approach today because being digital, getting to digital infrastructure is a mandate today globally for all manufacturing customers. Having said that, start small, start with a business use case. It can be at a plant level, it can be at a line level or a machine level, as long as it is a business outcome driven initiative and making sure that you are thought through every possible aspects of it. When you have to scale it to other lines, plants, the projects is usually successful. So that's what I see as working. That has been our approach as well.
Okay, fantastic. Thank you for that insight, Pugar. All right, Andrew. So let's assume there are situations where agentic AI is actually working. What changes in the day-to-day life of the operator when that is the case, and how does it look different from just another alert or just another dashboard?
Hmm. Yeah. So, I guess I wanted to start with one of the agentic AIs. I think it's important for every company to eat their own dog food. Like one of the ones that we built that works very well now is actually an agentic AI that does PLC tag mapping and connectivity work, which is actually our job, right? And to do that faster. And that's something that for the customer changes how much of the weeds they have to be in and calls back and forth to talk to us about this and that protocol and just like map these things faster. Now, go a level above that. Like what we're trying to deliver to the customer is a guided action of how to fix a machine or fix a quality issue or fix their plan, right? And if agentic AI is actually working, the experience that they have, the old experience they had was an alert went off, or maybe they didn't even have an alert. The alert was isolated in this machine, this MES. The right person had to know to look at it. Then they had to start a whole human-led RCA, root cause analysis, right? If the agent's actually working, the agent sees the alert first. The agent goes and looks at everything, gathers the right data, puts it together. And by the time the human opens the ticket, they go, in theory, the answer is completely figured out and it's correct. In practice,
Mhm.
often it's partially figured out and you gathered some great data. And this gave me a jump start and I'm going to get this done faster than before. So, we measure the mean time to respond. And I think one of the misconceptions is that like agentic AI just takes jobs. Like, I don't know, you have 50 amazing quality technicians and they're going to be gone. And the unfortunate reality is actually that most plants only have one or two left, and they are stretched just entirely thin and out of time. And so the experience is partially of getting work done by this automation, the same way of a physical automation. Like I don't have enough hands to just lift everything. Let the machine lift it. I don't have enough minutes and brain power to look at everything. Let the machine look at it for me. And if it's done right, again, this is the solution side. It's coming with a fully correct answer, at least a half correct answer, and an understanding of how it got there and what data it used. So this is grounded versus hype. And now it's easy for me as a person to pick up and finish my work. And I'm going to get three things done in the time that I would have gotten one done. And then hopefully your boss gives you at least two times more credit, if not three, for doing it, right?
Okay, yeah. Are you sure that really happens? I'm not sure I am. But anyway, what about, so when we look at the most experienced operators, how is AI able to extend their expertise, and how does that change then what you get your best engineers to be spending their time on? Because, a lot of the benefit of AI, at least in theory, is the fact that you're freeing up time in order for the real people to spend it on higher value work, right? So is that the case?
Yeah. Yeah, I'll take that as a quick follow-up.
Yeah,
Yeah. I mean, 100%. If you go back to the picture that you don't have 100 quality, amazing engineers sitting there in a plant.
right.
That's not everyone's reality. You got one, two. If we talk about planning, I often see it's the person managing inventory or Kanban who's also asked to manage a spreadsheet, and maybe there's not even a single dedicated planner anymore. So in that case, it's like creating an expert planner and there wasn't one. In the quality case, you've got to have a couple amazing quality people in the plant. And the idea is they're going to dig into the harder problems. So if this is a routine, if the agent just needed to read the log file and tell you, yeah, that one part was bad, and it was so easy and obvious, they get to just check those off and they get to go to the nasty problems that don't have any data, the ones that require you to put your ear against the machine or look at the board and kind of like however they do it. They spend more time on those, right? And it's a slow process of building an automation. It really is very analogous to the physical automation we've done for a long time. That's like you don't automate every hand. There's tons of hands in the factory, but which are the hands that should be automated to let us lift other things, right? Or press other buttons. It's the same with the mind. It's new for us. Sometimes we call it like a robotic arm for the mind. So it's kind of new and it's different, but it's kind of it's actually not so mysterious that it's happening now. I don't think it's purely a technology push and this, discovery of fire. It's like the thinking labor has been going down for a long time in these industries. The urgency is high. And that's why there's enough economic pressure to keep building these things because there is a gap to fill.
Yeah, absolutely. All right, fantastic. So now I want to get even more real because our audience loves real world examples. So Gary, I want to ask you now, what are you actually, where are you actually seeing AI deliver measurable results? So not in, pilots or press releases, but real world production running environments, been running for a long time. Where are you seeing those measurable results? And is there anything in common between those successful deployments that you're seeing?
Yeah. So the deployments that are working share one characteristic that doesn't make it into the vendor case study. They all solve the data foundation problem, like we've been talking about before they deploy the model. The predictive maintenance is probably where the most credible proof exists today. I think Dave and others, we kind of talked about that earlier, especially on high value, well instrumented assets where failure modes are known, and the cost of unplanned downtime is significant enough to justify the investment. The compressors, turbines, critical motors, those type things. AI is reliable there because the data pipeline was reliable before, right? Common factor in these that we're seeing, and I don't have any that are named in any customer case studies. We don't have permission to do that, but the common factor in every working deployment I've seen, the OT data being normalized, before the model was being trained, not being trained on different different clean data inside a lab somewhere. So those Modbus, registers we talked about earlier, I remember early 2000s, I was still in development, and one of the quotes I remember was, "There's over 6,000 variations of the Modbus protocol out there. Everyone had their own version to speak to different kind of disparate kind of hardware systems." But, DA devices translated into OPC we talked about as well, MQTT with the correct engineering units, consistent name tagging, UNS kind of comes into play here. You have to architect that. It doesn't come in a box for you to install. The timestamp integrity as well. Training on raw data, is inconsistent. It's really protocol fragmented data. Don't generalize. They memorize the noise, right? When you're kind of looking at the raw data. The second common factor we kind of see is the deployment didn't require opening the OT network inbound connections. That's security again, because why put this major investment in and just open the attack vector on the outside of your network. Outbound only is the only way to go, but you have to have something that's architected at that side as well. If you need to get data from your OT environment to IT, that's the whole conflict that kind of it keeps raging along. But we can actually architect that and put software in order to satisfy that as well. So really what's not working, I guess, is really the AI platforms that are deployed on fragmented multi-protocol OT environments without any kind of normalization layers. So if you fix those, you have a better chance of success as well.
Okay, fantastic. All right, thank you. And shifting gears now back to the physical world, and Dave is our self-confessed expert on the physical side of things. Dave, I wanted to ask you, how should manufacturers think about power, cooling, and control systems as AI workloads move in to real production environments? And even though, we know, as what you said at the beginning, they're not there yet in a lot of cases, but what about those requirements, power, cooling, and control systems?
Um, it's actually a big question because it alludes to the fact that the AI data center, which is the power hog today, right? So,
Mhm.
which is true. The amount of computing power necessary to really do the calculations and to run these algorithms is massive, and the amount of data that's coming in is massive. I don't foresee that the production facilities are going to have gigantic on-premise data centers. They will have edge. There will be data centers at the edge. There will be some light data centers at the factory. So there will be some increase in power and cooling from that perspective. The other perspective, so you have to split these two things. Even if the data center or the edge data center is not in the factory, making a smart manufacturing line does use more power. That's, I think, what we're all talking about. You need sensors on everything. You need, visibility on it. It can't just be a sensor. It's a camera. The cameras will have their own system that they're working on. There will be more motor control. There will be more touch screens. There's more PCs involved, right? So you just end up using a lot more power on the assembly line than you did when it was just people on that line. It is what it is. So the power draw for a truly AI-enabled smart manufacturing line, it's got to be twice as much, no doubt. It's big. And the cooling is a cooling. It's again not a data center, so I don't think it's going to be any different than your heat load that you would have today, right? So the equipment is pretty efficient. It is so efficient. I actually think a human body probably generates and throws off more heat than some of these, servos and drives because they're running at 98% efficiency. Um, control. Control is big. And I think this is, as I was saying, and the whole panel is saying, are you really thinking through this? You are not using an old school PLC. You are not going to be running 300 different protocols or some of these slow serial networks. You're not, because the latency is a problem. You've got to get that data up to the cloud or to the edge. That data's got to come back down. You have to distribute the control. You will be using your control will be more on the high-end PLC or likely an IPC, right? Industrial PC. So everything is moving up, which shouldn't surprise anyone. I mean, today it's pretty hard to find a 16-bit chip in any product, right? You can get a 32-bit chip from anybody, and almost everything coming off the assembly line has more computing power than it probably even needs. Memory is a problem, so that you don't have enough memory in these pieces of equipment, which is where you'd have to store things for on product, AI. Uh, but I do think the control is a very big piece of everything we're talking about. How do you have the right control on machine? How do you have the right control on the manufacturing execution system layer? And which means on the assembly line layer that is feeding up to the full MES, how do you get all the way up to your ERP? How do you network all of that? I do think, as Pagal said, you're going to have to get IT involved more than they are today. It has to be unified across all these facilities. Control is massive. Power, not so much. And cooling, I think we're good.
Okay. Fantastic. Thank you very much for that very practical insight there. All right, so guys, it's time to get your crystal balls out. In the last section, we like to take a look into the future and also try to give some pragmatic advice to people who are, look maybe not that far into their journey on this and looking for the best places to start or, avoiding mistakes. So, Gary, if I could start with you, for the operations leader in the audience, what should they do first when they're approaching these types of projects? And what are the two or three questions they must absolutely ask any vendor before they sign a contract?
Let's just start with the questions first. We've talked about them ad nauseum here today, which is your data layer, architecture of that, your legacy systems and data protocols. Do we have an answer for that by the vendor? Is this something they incorporate, or is it a third party they depend upon to bring that data, translate that data from an old legacy protocol to a more modern protocol? The second piece is the architecture of your security of your OT network. All this is not if you again open up your OT environment to bad actors, hackers, and things as well. But really, many of the operators have been burned before, and it was really certainly around not maybe the model, but the data pipeline, right? Why don't you just take some time and do a 90-day project to establish a normalized outbound only OT data pipeline, but also that structure of your whole environment on the data piece of it, but also on your organization. Do an actual audit of that and make sure that you are prepared before you start throwing technology at these things. And then fix that first before implementing the AI, whether it's at the edge where the operators need it, it's fast, or if it's in the cloud where you're going to have multi-site, multiple systems, a lot more large data there as well, looking for improvements in your process and things.
Okay, fantastic. Good practical advice there. Thank you, Gary. So Dave, which AI applications in industrial automation do you think actually are going to are going to transform operations once we get to that point? Most businesses get to that point. And are there any trends that you're seeing that you don't think are getting the attention they deserve?
So, which AI would transform operations?
Hmm.
I'm going to be very practical from the physical side, because
Hmm.
again, it's where I reside. Uh,
Yep.
quality control. So
Okay.
I don't think anyone's expecting me to say that, but the quality is it's massive, right? You can put a system together that runs, but you have to have the quality control. If you could capture and fix that with AI, which means, in production verification, in production, vision systems, which Vision's already using some AI, right? But again, most of that is pick and place. You're looking at a bucket of stuff and you're looking at it and you're picking and you're trying to decide what movement to have and where to put it. Yes, in the produce side, you're getting rid of bad apples and you're keeping the good apples. But I'm speaking quality in real product that we're building. Uh, if you can get the quality control to be perfect, I mean that's massive. Everyone expects it. Quality is something people expect from everybody, whether it's low cost or high cost. The implement implications of that are huge, right? You don't have to have after sales service. You don't have to have all these problems. You don't have to have, follow up on how you produce things. Quality is just massive, and that's from the front end on raw material through the production and through the end product. If AI could really solve that, which they're working on, right? That would be enormous on the operations side of a factory. The next one, man, it's adaptive AI. If you're asking me more specifically about what AI would be versus what application, adaptive AI, right? The ability to self-correct and to do all these things. If you could have an assembly line that could adaptively change on its own to the next product portfolio versus finite recipes, or you just had an infinite capability, which is almost unrealistic right now, it would be incredible. That would be my dream. An assembly line that can make a truck and tomorrow it makes a little Geo car and can do anything, that is unbelievable. We're a ways away. Yeah.
Okay, fantastic. Thank you. All right, Pugal, please, can you have a look in your crystal ball and tell us what you think is coming down the line from your perspective?
Um, the biggest change I saw happening, which happened in the last 1 year time frame, is the agentic infrastructure.
Hmm.
Because even 1 year back, I had to build, I'll take a real world example. I had to build and launch an OEE solution accelerator on Snowflake. So, which is reusable across all industry verticals. So it took like really smart, two smart developers I worked with, and it took around 12 weeks time frame to build a solution which can be applied across all industry verticals. If I had to build something similar, which I did, it is done in a matter of half a day or less with AI-based coding. If you know how to build it, if you are very clear about the business use cases and you know from the industry, AI coding changed everything. So getting value out of data has never been this simple. So that's why I always tell the customers, identify your business use case and make sure the data is available in the cloud infrastructure like Snowflake. We can get business outcomes much, much simpler, even compared to 6 months back. So that's where the industry is today. So exciting times. That's the way I look at it.
Okay, fantastic. Thank you, Pugal. And Andrew, your thoughts on the next big steps we're going to make in all of this in the manufacturing environment?
Yeah. So I won't repeat, I loved all these answers, Dave. I love the quality and the self-configuring line. And I've been saying use cases this whole time, planning and quality and process engineering. That's where real value is. So
Hmm.
I'll give something different for this final one. I'll give a technologist's answer because I pay a
Okay.
ton of attention to the underlying models and where they're going. And what I think what we're just leaving with AI was the introduction of multimodal analysis, which meant unstructured data. And that's like I never thought of that before. It could read a manual. It could read the screen, the HMI on the screen. It can read a picture, not the traditional AOI way, but like just the generative AI can understand a picture. That's like in use today, and that was mind-blowing for folks about a year ago. And then what Pugal just said, if anybody on this call hasn't internalized this yet, AI can code extremely well. It's at production. And if you haven't thought through the implications of AI coding, that's the first thing you need to do right now because it's mind-blowing. 4.6, Opus 4.6, Anthropic especially, also Gemini Pro 3, that was 6 months ago. That was a fundamental change. And you can now give AI like a graph of data and let it write its own queries, not just like tell it what it's supposed to query. It can query by itself. So you suddenly can build data graphs that are far bigger. In the chat a bit, people were talking about tag mapping. Yeah, doing tag mapping, that's code. Anything in code, AI can code. And then what's like coming next is there is hundreds of billions of dollars going into world models next. And world models is the idea that you can take this expanded digital twin, data twin. NVIDIA is almost a little too far ahead talking about Omniverse all the time. But the reason is because you take that even greater set of data, and this is why people are getting hyped about the humanoids like Bezos's Prometheus and everything, is you might actually be able to give thinking like reason to robots and everything, right? Now, I think that is in the 5 to 10 year horizon, but it's going to start influencing the way people think about data. I think now, take a step back from that again. I'll close with this again. Think about AI coding. The implications are so massive, and that is now mature, and manufacturers haven't grasped yet like what that changed. And it's extremely exciting, and it has a lot to do with the types of use cases we were talking about, like the quality one that Dave talked about, like put code in the hands of the AI and it can go. So I'll close with that technologist answer to add to the prior use case focus, which is still the top thing.
Yeah, yeah. No, fantastic. Thank you very much for that, Andrew. And we do have a couple of minutes to go to some questions. And given that you just mentioned multimodal there, we have a question which asks, have you seen multimodal agents in action at scale in factories already? And so Andrew or any of the rest of the panel.
I should take it. We do it ourselves. So we
Mhm.
have more than 10,000 agentic flows that run per week across hundreds of factories, and they generally all use multimodal analysis. They generally all use screenshots of dashboards as part of the data graph. So, for example, they'll use tags and PLCs and log files, but they will literally, we go into the UI of a machine and we screen grab it. Why do we do that? Because on the screen, a thoughtful engineer has spent years or decades thinking about how the graph should look so that it becomes obvious when a person looks at it that this is a problem or not a problem. And so that multimodal data set is the way that an agent thinks, right? So that's something we put into production about a year and a half ago. And it's not the only data source by any means. Again, hype. Some people, there's nobody on this panel is saying this, but there's some people out there like, oh, we could just skip PLC data altogether. That's totally foolish. But has these images of graphs and like pictures of structured data added a new thing for AI. It has. It's amazing, and we use it, thousands of times every day in our prompts.
Fantastic. Okay. Anybody else want to talk a little bit about multimodal or anything to add?
Nothing here.
No? Okay. So next question. For large industries with different types of operational lines and processes that involve many changes in their sensors, what have you observed in the implementation of predictive maintenance? Is it using more conditions, specific failure mode prediction, or the use of anomaly detection with AI?
If I have to take a shot at it, Hamish,
Yeah.
the foundational thing where we see challenges is customers don't have anything to predict in case of predictive maintenance, which means that they have not even started collecting the data. They have not monitored and identified the conditions which they have to predict. Usually, the first step in the process is collect the data with respect to whether it's alerts or deviation from the process, whatever you are collecting from the machines and from your maintenance system, CMMS. Do a condition-based monitoring first and identify the conditions which you need to be concerned about. Once that is in place, you have something to predict because that's the first step of the predictive maintenance journey. Even there, if I look at with pretty much every major implementation happening there, most of the customers are trying to work on KPIs like mean time before failure, mean time to repair, to make sure that mean time to repair is as fast as possible and mean time to failure is as long as possible. That's a goal and get to a basics of condition monitoring. If these things are lined up, usually the customer is in a good shape and mature enough to move to a predictive maintenance. Otherwise, they have nothing to predict. So this is our assessment, at least.
Okay. Fantastic. I want to ask a question now, which Andrew has actually provided one answer in the chat, but I wanted to ask it again to the rest of you because I found it it's one that hasn't come up to me before, at least. So we all talk about use cases all the time, but Scott has pointed out that from a manufacturer's perspective, they actually talk about problem statements. And sometimes manufacturers find it difficult to create those problem statements and put a good one together. So I don't know, maybe Dave, as you know, you work for a manufacturer. Do you have any thoughts around that?
Um, do we make problem statements? I mean, your question goes, it almost sounds like Pugal's comment, right? Uh, do we make the problem statement? Do we try to solve the problem? Of course we do. And do we try to understand exactly, what that problem is and make sure that we work around it? I would tag on to what Pugal said, that people don't know what they need and they don't know the problem statement. If I look at predictive maintenance, the only people who really can do predictive maintenance problem statement are the ones who made the machine, right? Because
Mhm.
they know what that product should be doing. They understand it. If I break it down to a more simplistic motor control, we know the voltage, we know the current, we know what that motor back EMF is, we know everything about it. So if you had a pump skid, we know all the things we need to know to make sure that that system is running. And we can write the problem statement for a AI system to say, I get it. This is what you're looking for. We can give it all that data. If you have a third party company or just a manufacturer, I, I think it's very difficult for them to take a third-party product or a machine they bought and build predictive maintenance on it, which is the same thing. Like, how do you write that? How do you know where the problem is? What are you looking for? Um,
Okay.
you've got to really dig deep. You have to own the data.
Fantastic. All right, we have run out of time, unfortunately, guys. So it just remains for me to say thank you very much to all of you panelists for your great insights and knowledge, and thanks particularly to the sponsors of the session, Arch Systems and Skynet. Your support ensures we're able to do this, of course, at all. So we're incredibly grateful for your support. Thanks to all our attendees for your great questions. And it's now time to move to today's final session, which is manufacturing cybersecurity in the age of AI, sponsored today by OpsWatt. So enjoy that one. Thanks again to everybody involved, and I'll see you next time.